Hey, how you all doing? Welcome to Project Workshop's first ever live stream, or in fact, first ever video on the whole channel. This channel is gonna be about electronics design and all kinds of other projects that I will be doing in my free time. I thought that for the first time, or the first project ever on this channel, we're gonna design a simple Class D mono channel, that means a single channel audio amplifier. People often think that electronics design is hard. It can be, not gonna deny that, but there are many applications that are quite simple to do, and in fact might just seem hard to begin with. So let's get on with today's project. A Class D mono channel audio amplifier. So we are jumping. Let's jump into DigiKey after I first find my, there we are. Now we are in the right place. So let's start at first navigating our way into the audio amplifier section in DigiKey. We're gonna go, you can either go from the left from the integrated circuits, or you can just scroll down into the integrated circuits. And it is audio amplifiers are under linear amplifiers audio. Seems simple enough. So today we are going to be making simple as possible low power. This is not going to be a high wattage amplifier, but it's going to be simple as possible. We're going to keep things KISS, keep it simple, stupid, and we are going to go with a simple setup. We are not going to go for anything fancy. This is going to be a beginner lesson. You're going to see how to use the DigiKey website to look for electronic components. I'm going to show you how to use the filters effectively, and then after we have looked around and seen and found a suitable looking integrated circuit, we are gonna check the datasheet and see if it seems reasonable in there. And then if it does, we are gonna select that component, and then we are gonna jump into KiCad and start actually designing the board. So first things I would always recommend when using DigiKey for looking components is that once you have selected a certain category of components, I would always, or I personally would recommend always checking part status to be active, and also select only components that they have in stock. Not now, selecting only active components, I would say it's best will be to always select active components. You don't want to buy any old components, or maybe something that is just coming to market. But I would active is that very usable. I would say select that always, and then also in stock. Why would we be looking for components that they don't have in stock? Okay, sometimes they run out of actual good components that we might want to use, so there is a time and place to not use the in-stock filter, but we're just going to go with the part status, active, stock status, in stock. Apply. Now, this I would say that is always the first filters that you want to select. Now, because we want to make a Class D amplifier, we are not doing A, B, or anything else. We want to just select Class D audio amplifier. And we can already see that we started with something like 5,500 components, and we have just with these two first filter selections, we have already reduced that by 6-fold. You could start looking for components without using any filters, but there is just so many different components to select from. So just please do yourself a favor and just learn to use these filters. And I mean, just go and check out what all kinds of filters there are. You can just reading at what they, like what possibilities there are, you can really reduce the possible amount of components that you could have. Like there's so much, and it will narrow down the possible selection of components so much. Okay, sometimes you don't know what you should be selecting, but I digress. We need to find our monoclass deamplifier. Okay, so we have a class deamplifier selected. Now I would say we want to select the output type to be a 1 channel or the mono. Now we could go for an other mono channel setups, but those are more for stereo setups or like headphone amplifiers. So we are not interested in that for the moment. So 1 channel mono. Apply. Once again, we have reduced our possible component selection down by 2-fold. Next thing is that we want to run this amplifier from a single lithium ion cell, like I have one here, like one of these. This is a 18650 cell. These are the same kind of cells that are found in the Tesla Model S laptop batteries. These are the most, I would say, the most used battery package in the world at the moment. Now, for the sake of not digressing, let's not go further into this topic yet. Okay, so what is our range of supply voltages that we want to be looking at if we want to operate from a single lithium cell? Well, at full, like when the cells are full, they are roughly 4.2 volts, and when they are completely empty, it's like 2.5 volts. So I would say look for anything. Okay, let's see. Well, I would say anything that has that range, from anything that starts below 2.5, maybe 2.8, and goes above, I would say, 5 volts. Those are the ranges that we want to select. So that is good. That is good. It's gonna select multiple. Nah, I'm gonna go a little bit higher. Oh, actually, I don't want that. Do I want 2.8? It's a bit high. Oh. Yeah, I'm gonna eliminate that 3 volts. And also, I'm selecting multiple components by holding down Control and then just clicking around. Okay. Once again, we have almost reduced our component selection by 2-fold. So let's apply again. Now we might want to go and select what possible, like what's the maximum power that we can get from the amplifier to a specific load. But before doing that, I will say that we might want to select a certain kind of packaging type for the components. So without going further into what the differences are between all these types, I would say select cut, tape, and tube. That is going to cover like the most amount, because you might have the same component, but it's like listed 3 times because it has a different kind of the way that it is packaged is different. So cut tape is pretty good, I mean, for hobby use. We are not interested in tape and reel. We are not doing high volumes. Strip, not really. I would say just go for cut, tape, and tube. Those are the small volume ones. So let's apply those. There we go. And now there's only 122, and those are very likely to be 122 unique components, not repeats, because of different packaging types. These are unique ones. That is still a little bit high for my taste. But for example, if we just look down, I would say let's sort by price. Okay, we have a couple of under 50 cents for a single piece. Okay. Yes. Looks to be a good selection, but okay, let's reduce the number of components to select from a little bit more by going into the max output power. And I'm gonna say that we are interested in, we can go from the max power, I would say like 2.5 watts into a load. And as we can see, we have once again reduced the available components by roughly 50%. Okay, now we want to start actually looking at the components more specifically, because now we have to actually choose one that we want to use. Okay, well, let's just check out the cheapest one, which is coincidentally actually one of the more powerful ones, at least maximum output power wise. I mean, it's a decent looking component, but there is one very specific thing that I don't like about this package, to be specific, and that is that it's grid array footprint. Okay, what does that mean? That means that the pins on the bottom of the package are arranged like this. Like if you don't have hot air reflow tools, I would say you are pretty much shift out of luck trying to get that soldered onto your PCB. So I would say if you are a real beginner, don't go for, what are these actually? These well, generally anything like BGA, ball grid array. Avoid those. Those are going to be for, I would say, for very high density designs where you really have to, you have to cram a lot of components into a very small board space. So for the sake of being a beginner tutorial, we are gonna eliminate all the BGA packages from our list, so we can do that. More filters, I would use the package case and not the supplier device package. So anything BGA, okay. SOIC, anything, these are good. More UFNs are good. Yeah, there we are. And as we can see, there are a lot of BGA components because we have cut the amount of components down like 2/3. So this will be, I would say, this is the ideal situation that you want to be in after using a couple of filters. You want to have like a couple dozen components left, not much more than that. Okay, so I don't know, are we looking for a specific package? Not necessarily. but I would go for, wait, okay, if it's gonna be a Babby's first audio amplifier, I would say let's not go for GUFN packages that have that exposed pad underneath the package, because that is gonna be a tricky thing to solder on if you don't have hot air reflow tools. So we're not gonna remove them from the list, but we are gonna start just selecting components and jumping into their datasheet and seeing what kind of specifications they have. So here's one from Diodes Incorporated, PAM 8302A. And here we can see, actually, usually if you're wondering how an IC, an integrated circuit, is used, just open the product page, open the datasheet, and just go look for a typical application circuit. There is usually a picture that the actual manufacturer has provided in the datasheet that shows you, like, this is usually the minimum amount of components that you have to have if you're going to use this IC. And as we can see, there really isn't a lot connected to this IC. You have a one decoupling cap on the voltage supply, and then you have one resistor for each inputs and a series capacitor, and that's it. There's nothing else. It's 5 components total. That's all that you need to have. As all that you need to have or add for this IC to work. So in that sense, this is a very good component. And in fact, most of these low power audio amplifiers are going to have typical application circuit just like this. You're going to have those 2 input capacitors, 2 input resistors, and then you're going to have a supply voltage decoupling cap. And then most of these you can use without any extra filtering on the outputs, and then just connect your speaker to it directly. So, okay, that is one. This particular pin out, where the ground and the voltage supply pins are next to each other, is, in my view, pretty good, because you can very easily decouple your supply voltage, because you can just place your ceramic cap like right between these pins or next to them. Okay, and then we have another thing that you need to think about is the shutdown pin. We're gonna make a simple way that you can sort of bypass that shutdown button. But if you want to use like a power on-off switch, we're gonna make it also in the actual PCB design that you can easily hook up a switch to it, so you can turn your amplifier on and off. But I'm not gonna lock down this component yet. I'm gonna leave the tabs open in my browser, but I'm gonna check a couple others first. Oh man, this is a bit annoying. Personally, I would have no problem using a GUFN package because I have hot air reflow tools. But if you're gonna make a simple Class D mono-channel audio amplifier, I guess we're just gonna make... we're gonna make it. We're gonna choose a package that you can solder on without owning hot air reflow tools. So just you're gonna only need a soldering iron to assemble this PCB once we're done with it. So is there anything higher power? That is a bit higher power. And so is this one. Okay, I'm gonna take a peek in both of these data sheets. Okay, what model is this? Well, it's an MSUP package, so it can't be either one of these QFN ones, because I mean the MSUP doesn't have the exposed pad underneath it. So I would expect it to have this. Is there actually? Okay, so it has this pin out here. Okay, it's a bit annoying. That is a bit annoying pin out to do a simple component placement and routing the traces on the PCB, because I don't like the fact that the ground is on the. Actually, you know what? Let's just go. Let's keep it simple. Babby's first audio amplifier. Let's keep it simple. Let's just go with this first one that we looked at. 2.5 watts is decent. I mean, most you are going to be limited in these low power audio amplifiers is actually your supply voltage. Without raising the supply voltage, you are limited in the amount of power you can get into the speaker. So in that sense, I would just say just like 2.5 watts is pretty good. Actually, let's take a couple more closer looks at the datasheet. 2.5 watts output at 10% total harmonic distortion with a 4 ohm load and 5 volt power supply. It's decent, and we're gonna go with it, in fact. Okay, so this is going to be our audio amplifier IC that we are going to be using today. So, having selected that, I would say it's time to jump into KiCad. So, let me do a jump here. There we are. Let's create a new project for this audio amplifier. So I'm gonna go File, New, Project. Then I'm gonna go into my Project Workshop Google Drive folder, and I'm gonna give, what would be a good name for this? Let's go for Mono Audio Amp Beginner. Save. And it's also gonna create a new folder for us in there. Okay, let's jump into the schematic. Okay, so let's pull back that. Let's jump quickly back into the datasheet and just see there. Okay, so alongside the IC we need 2 resistors and a total of 3 capacitors, so let's add those in first. So I'm gonna press A to open add component menu, and then I'm just gonna input C, and it'll first thing it'll show you, we just see, is a capacitor, which is what we want. We're gonna slam down 3 of these. Or actually, we're gonna slam down 1. 1, and then we are gonna hover over that. We're gonna press C for copy. We're gonna make 2 more. There we are. There's our 3 capacitors that we need. Then we're gonna add our 2 resistors. So once again, press A. Oh, it's good now. I have my just had my friend message me that I was having a wrong screen open right there. Maybe I need to get a 3rd monitor. Actually, I'm just gonna minimize this one. Here we are. Okay, so what we did, we added our 3 capacitors. Yeah, we're in the right window at the moment, so we have our 3 capacitors. So I'm gonna press. So let's add our resistors now. So A. Then let's input just R. It's gonna pull a resistor, and then we are gonna slam down 2 of these. And once again, I'm gonna hover my mouse over it, press C, it'll copy that component. Now we want to add our audio amplifier IC. Most likely, not necessarily, but I think there is a possibility that even though KiCad's own like schematic symbol libraries are pretty good, you have a pretty wide range of different components that you have in there, you might not have this particular audio amp that we are looking for now. But let's see. So our audio IC model is PAM A302. So I think if we just put in PAM A3, if it exists in the library, it should pull up the IC with just that. So let's jump back into KiCad. And let's just go PAM 83. And luckily for us, actually, we were almost lucky. Or actually, are we lucky? Which one? Yes, we are lucky. This is the correct one. Ends up Soik. Okay, all of these have the same. I'm at the moment I'm looking at the pin numbering on the schematic symbol, and I'm seeing that all of these 3 have the correct one, and it's identical between the different models. So this one is a DFN package. We don't want that. It has that exposed pad underneath the package. Hard to get it soldered without hot air reflow, so we're gonna skip that. And so is it a Soik or a MSOP package? I'm looking at the description down here, but it doesn't really matter because we can change the package later. So for now we can just select one of these. Bam. Okay, I'm gonna rearrange my components a little bit. I'm gonna, for example, move this IC name tag. I'm gonna move my mouse over it. I'm gonna press M. I'm gonna move that to below the IC symbol, and I'm gonna bring my reference designator. Maybe I should put it on the. Maybe put it on this side instead. It's fine. Okay, so now we are just going to pretty much copy the typical application circuit from the datasheet. So check. So we have that one capacitor on the pin 6, positive voltage, and then on the input channels we have the series capacitor first, and then we have the series resistor. So let's arrange our components like that. So we're gonna have there. Ooh. I'm gonna split them up a little bit so that the texts don't overlap. So we're gonna choose those two here, that one there, and then what will be the best way to put this capacitor? Okay, I'm gonna put it on the high side, or the top side of the audio amp schematic symbol. Now let's add a couple of power supply schematic symbols. Specifically, we want to add a ground symbol. And once again, I usually just, if I use pretty much any component, I just slam a single one into my schematic, and then I move my mouse. If I need more of the component, I just move my mouse over and press C, and then that way I can just copy that symbol more. But yeah, we need another ground here. Yeah, I'm gonna move that a little. Nope, don't want to select that. Gonna move my keyboard directional pad, and we're just gonna place. Okay, so we're gonna be configuring this the audio inputs as a single-ended input, and that means that the negative input will be grounded. So it will go. We will connect them like this. And now I need to just add a positive voltage supply mark. I'm gonna use a plus 5 volt, and I'm gonna put that there. Okay. Now, actually, before I add more components, let's wire this up now, and let's add a couple more. Oh, let's add some connectors to the board after that. So now we want to start. Now we have some components in our schematic, and now we want to start connecting them electrically to each other. So the way you do that is also if you want to move your schematic around, you can just use you can click on your mouse scroll and then you can drag, or if you want to move more quickly, you can just move your mouse pointer to a specific location and just use the scroll wheel, your mouse scroll wheel, and you can use that to zoom. And by default, KiCad always centers your window to where your mouse pointer is. Maybe that is the best way. Okay, so let's start connecting all these components. So the way to start drawing a wire, you can, of course, you can always use the actual graphical buttons on the side here, but it is much more efficient to learn the hotkeys and use those. And if you're wondering what the hotkeys you are using are, you can just go to Preferences. Actually, where are they? Maybe Help. Oh yeah, there we go. List hotkeys, and here you can just check what everything is. So, for example, if you want to begin drawing a wire, it is W. So with that, and it'll start drawing it at the location where your mouse cursor is. So if you press W, it'll start drawing the wire right there, and then so move your mouse over to the place where you want to start drawing your wire, and W. We want to connect the input to this, and then we want to connect that there. Negative audio in to there, 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 and then you connect the negative input. This is going to go to ground because we are using a single-sided audio input. We are not going to use differential. It is a little bit more like for professional use, so to say. It's more audiophile, but we are. This is not going to be like super ultra high grade amplifier. We just want to get some. We just want to get some music out of this thing, you know. We are not that concerned for now with like high quality audio, although these do actually sound pretty good. But then like the amplifier block is pretty good, but then it is much more dependent on actually your like what your speaker, or how well your speaker is made and how the enclosure is matched to the speaker. But anyways, I digress again. I have a bad habit of digressing, but I don't know, maybe people like that. Maybe people like when I ramble a little bit, because I have a bad habit of doing that. Okay. I'm gonna do. Okay. Here's a couple of tips. If you want to move a component that has a wire drawn to it, so if I press M on the ground symbol and move, the wire will not move with it. And Ctrl C to undo that. But if I go on the symbol and press G, which is drag, then it will preserve that wire connection. But because in this case I only want to move this symbol down a single snap, I'm just gonna go move my place my pointer above the ground symbol, press G, and press down, enter. And then I'm gonna put this ground symbol on the same level as this one. So I think it's down 2 levels. Generally, like this is a more advanced way of drawing schematics, but generally you want to have your, for example, ground symbols and or your like positive supply symbols, like they should be like on an equal level on the higher side of the schematic. It just looks more neat and is easier for your eyes to like quickly discern like where everything is. In fact, I'm gonna move these two. And also, if you want to move multiple components and you, rather than just moving like this and it breaks the connection, when you select them, press Tab, and then it will also drag them again rather than just moving them, which would break the connection. There we go. So for example, just to reiterate, if I select both of these and I don't press anything, it's just gonna rip them off from the existing connections. But if I press Tab and now move them, now you can see that the existing wire connection is preserved and I'm still able to move these around. So, but okay, I mean, we're almost done with the schematic, and it has been like, I don't know, 15 minutes, 20 minutes, and that's most of that has been just me like rambling. But okay, now we need to add a couple of connection points. So for example, we need a connection point for our audio input for the signal. We need a speaker output connection. We also need a connector for our positive voltage, and then we're gonna put a connector for the shutdown. But we're gonna use a footprint that you can just make a solder bridge over it, and or you can just solder in a pin header and just put a like a short circuit block onto it. So let's add some 2-pin connectors. So A again for add component. Then we are gonna enter con. Now we have we can select like what kind of connector. Like KiCad does differ. Like this is the biggest thing that differentiates KiCad from other PCB design software. Like 95% of the components that you add from this add menu in the schematic side, they don't have a footprint associated with them. But personally, I would say that is a good thing, because it just makes designing, or if you just want to do the schematic design, it makes it so much faster, because you don't have to have like ready components. So for now we're just gonna go 2-pin connector, and I'm gonna use male. You can use a female if you want. Doesn't really matter in this case. There's not gonna be like anything. How would I say? There's no difference in the way that we are going to be using them in this simple PCB. So we're gonna place one there. That is gonna be our audio input. Then we are gonna place one down here. We're gonna connect that to the shutdown pin. Then we are gonna place one, press R to rotate. We're gonna place one on for the speaker output, and then we're gonna place one for our power input. So also, if you want to, for example, if you look at these two symbols, they have their number 1 pin on top, whereas these two that we just rotated, they have the number 1 pin on the bottom. Doesn't really matter in this case, but for example, you can mirror the components using X and Y. If you hover your mouse over the component and press X, it's going to mirror it on the horizontal axis, like X. And if you want to mirror it in the Y axis, then you go over the symbol and press Y. Well, I'm just gonna... Oh, there we go. I pressed X, and now we have our number 1 pin on top. And for example, if I press Y on this one, it's gonna... Well, it's gonna flip them, but in this case it doesn't really matter which way we do it. But I would say let's connect our speaker output and our audio input first, because those are the most simple connections in this case. So, and once again, if you want to move something, in this case I want to move this value for this connector, I just move my mouse over it and press M, and it'll let me move it. If there's some multiple things that you can move on the cursor, it'll, well, for example, maybe here. No. Is there any? Well, there we go. If there are multiple things that you can move when you press command key, it'll ask, like, did you mean the field value, or did you mean the symbol? Well, in this case, I want to move the field value. But anyways, I'm just gonna neaten this schematic up a little bit. Okay, in fact, we are gonna use... Okay, I'm gonna move my mouse. We're gonna change the values of these connectors to be something a bit more descriptive. This doesn't really tell us anything, so you can change the value of component in 2 ways. You can move your mouse over the component and press V for value, and we can change the text here. For example, I'm gonna put audio underscore in, and now we can immediately understand, okay, this is the This is going to be the audio input connector. Then I'm going to move over here. V, it's going to be, I'm going to call this enable. Yeah, enable. I'm going to call this one speaker output. And the other way that you can change the value is you mouse over the component and you press E. This basically, this is, well, you can enter the same value. This is exactly the same thing that we changed for the other components, but you can also see all the other values for this symbol here. So for this, I'm gonna, what would be a good name? Power in. Yeah, let's go for maybe just power. I'm gonna put power in. Bam. Now we can very easily, with a quick glance, we can also see what these connectors are for. Okay, so let's connect them up. It's gonna go here. We're gonna duplicate that or copy that one. It's gonna go to ground. Then we are gonna connect the speaker. Actually, and also then if you want to remove components, you can delete them by del, delete key. And for example, if you go into a corner of a wire, it'll ask you, do you mean the, well, like which wire do you mean? Do you mean the vertical wire or the horizontal wire? As you can see, it doesn't, you can't, if I press del here, it's gonna only select the vertical right there. But I'm just gonna remove this. I'm gonna move this speaker connector up by 1 because I want it to be centered. Here we go. Now it's beautiful. Beautiful. Yeah. Okay. Let's connect power in. We can actually just do it like this. There we go. Now it's connected. Number 1 pin will be connected plus 5 volts and the other pin will be connected to ground. And now we have to connect our enable pin. So let's jump into the datasheet and let's read on how the standby shutdown enable pin works. So let's see. Here's the first page. Let's go forward. There is a pin description page somewhere where it tells what each of these pins do. Oh my god, it doesn't actually have one. Are you serious? It doesn't have. Oh my. Oh, actually, never mind. Notification. Oh. Usually the datasheets have like the pin outs listed somewhere, but in this case it doesn't, which is a bit of a bummer. But let's see if we can actually, let's check another, let's check the A303. Let's check, do they have a, well, okay, in this case they do have. And because it's yeah, this is a bit of a trick. So it's from the same series and it's from the same manufacturer, so these are pretty much like identical, but in this case the datasheet does actually have a pinout or pin description, whereas for whatever reason they didn't want to put one in here. Although if you are experienced in the art of reading datasheets, you can, if you know what this line above the shutdown means, then you can pretty much figure out what you need to do, or how you need to drive that pin so that the audio amplifier actually outputs signal. But there is nothing in here about how the, oh, never mind. It doesn't have a pin description, but it does have the shutdown operation, which describes in a bit more lengthier paragraph how the SD pin works. So in order to reduce shutdown power consumption, the PAM blah 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 contains shutdown circuit to turn off them blah blah blah. This shutdown feature turns the amplifier off when a logic low is applied on the shutdown pin. Okay, so what does that mean? Well, it means that if we connect this, if we connect this pin to ground like so, that would mean that that pin would always stay connected to ground, and it'll always stay in shutdown. So even if we have signal coming in, the audio amplifier is not going to do anything. So this is not what we want. What we want, in fact, is to do, let me think quickly. What is the simplest way to do this? Okay. The way we are going to do this is I'm just thinking over here. I'm having a brain fart moment. We're gonna add another resistor. We're gonna place it here, and I'm actually gonna move all these ground symbols further down because it's getting a bit cramped. Now I'm gonna move this resistor down here. Gonna move this enable connection here, and then I'm gonna duplicate our +5 volts power rail symbol, and then we are gonna connect the shutdown pin, the resistor like this, and then we are gonna connect the connector to this here. So what is happening here? Why did we connect this? Why did we add another resistor and then connect the signals from the enable connector like this? Well, what we have done here is we have this resistor is going to have a pretty high resistance value. It will act as a weak pull down resistor. So if these two pins are not connected together, aka there is no connection here like this, then that means that this resistor will slowly pull down the shutdown pin to the ground. So this, if this switch here is closed, then this resistor will pull this pin's voltage down to 0, and it will then disable, it'll then activate, and the low voltage on this pin will shut down the amplifier. So, but then if we connect connect pin 1 to pin 2. For example, we can have an external switch that we can flip. Do I have actually any switches anywhere near me at the moment? Give me a second, I'm gonna get a demonstration component. Here we are. Here I have a switch. It's a simple toggle switch. Again. And we could use this to short circuit those pins 1 and 2. So we could have one position on the switch off, for example, like this down position. And then when we flip the switch up, it will then connect pins 1 and 2. And what then happens is, if we connect pins 1 and 2 together, it'll connect this the Y volt supply to this. The 5 volts will be then directly connected to SD. Or maybe that's not the way. Maybe that's a bit more like legible. So essentially it'll be like this. So then, because this resistor is has a high resistance value, it will not be able to pull down the voltage on pin number 1, the shutdown pin, to ground, because we have connected the SD pin essentially directly to our positive supply voltage. So then it'll activate our amplifier. And then when we switch off, essentially this disappears, and once again this would float, but because we have this weak pull down resistor here, it'll pull this pin down to ground, therefore disabling the amplifier. And with that, our schematic is complete. And this is what it looks like. Now, the next thing we should do is to give these resistors and capacitors some values. So let's just give them some. Okay, this is just going to be a weak pull down resistor. So for a weak pull down, I would say it will be anything like between 100k or 1 meg. And this is just a display value. This doesn't affect anything else. It is just for so that the person who is looking at this schematic can see what kind of resistor value goes there. And in fact, I'm just going to remove that one. That's a bit weird way to. I'm going to put out 100k resistor there. It's weak enough, but not too weak. Then the bigger question is, what is the value that we want for our capacitors and input, or what is the capacitor value that we want for our power supply decoupling capacitor, and then what is a capacitor value that we want for the audio signal input capacitors and the series resistors. And for that we are gonna jump back into the datasheet and we are gonna look for it. Actually, does the typical application diagram? No, it doesn't have. Well, it does show a recommended value for the supply decoupling gap, so we can mark that. So that will be 1 micro. We can use a bigger one, it doesn't hurt, but like 1 micro is the minimum value that we would want to use for this capacitor here. And once again, these are just, you know, for the reader to check what value component you should be using. But these are more, the values that we choose for these audio signal inputs, these are more important in this case. So hopping back into the datasheet, we are just gonna go for like safe numbers here. If we want to get more, if we want to fine tune the components later, we can do that. We can just unsolder them and change their values. So we are not gonna use a lot of time to choose them. So we had maximum gain. This is essentially this maximum gain section will give you the value for the input resistors, and the input capacitor. This section here would give you the values for the capacitors part. Let me just take a quick look. I'm just gonna figure out some decent values for star. Do they have a block diagram? They do, but they don't show the internal feedback resistors. Well, I guess I'm gonna just have to go and use this. That is well, the second stage's gain is fixed at 2. Minimum. Oh boy. Oh boy. Oh, why would you not show a better typical application circuit? Ugh. Okay. Oh, actually, they probably have the feedback resistor value in here. But what? Please do tell. It's somewhere, please. Please. Actually, as a on-topic thing, welcome to the life of an electronics designer. This is it. It's gonna be just looking at components, crawling through data sheets, trying to figure out how to make the components work, what kind of value should they have, understanding how the IC itself works. Okay. What a pain in the ass. It really doesn't have. It really. Do I have to break out my calculator? Do I have to break out my trusty TI? You probably can't see that, but it's a TI 89 titanium. Good engineering calculator. Do I actually? Let's see. As shown in the block diagram on page 2, has two internal amplifier stages. The first stage with ratio to RF. But it already has a second stage gain of 2. So in fact, I think we want to go just for I think we might want to go for just gain of 1 for the first one. Then we have a total gain of just 2, because if our first stage gain is 1, it doesn't change the signal at all. And the second stage is double, then our total gain will then be 2, which from experience I think might be pretty good. So does it mean that our input resistor should be 80 kilo ohms or 10 kilo ohms? Set by ratio of RF to RI. Where are the RF and RI? Oh boy, they don't tell. Well, lucky me. This is a bit of a tricky business right here. Oh, minimum RN. I think the RF, the F stands for feedback. That means that is inside the IC. And I would guess that the RI is the input. So if we want to have a gain of 1, we would want to make our input the same as the feedback. Same as the feedback resistor, so 80k. Yeah. Let's mark them as 80k. Let's do that. So once again, V for modifying value, 80k. 80k. Oh boy. Well, I can for a fact say that a working value for these input capacitors will be 100 nanofarads, so we can just go 100 in. Okay. Okay. Now all our components have values. So, is that the correct one? A302, okay. Let's add. Okay, so what I'm doing now is just adding a little bit more data for the audio amplifier IC. So move my mouse over it, press E to edit it. I'm gonna press plus, and I'm gonna give it field name of MFG for manufacturer. I'm gonna jump to DigiKey. I'm gonna go manufacturer, copy, paste. Okay, and then I'm gonna go MFG number. This is gonna be the manufacturer part number. Then I'm gonna jump back into DigiKey, and again, it's gonna be manufacturer part number, copy, paste. Now we can find, just from looking at the schematic, we can see that this IC is in fact manufactured by Diodes Incorporated, and it has this kind of manufacturer part number. With that, we can, for example, look for this same component or on a multiple supplier pages. But finally, let's not go further into this section. Let's actually, okay, next step. We have to annotate the schematic. And what does annotating the schematic means? Essentially, it gives the reference designators, it gives them their proper numbers. So we can do that from, go up here, there's this little paper with a pencil on it, and it says annotate schematic symbols. Click that. Okay, you can use the default settings. We don't, these are, well, I personally also pretty much always use the default settings, so just annotate. And now, as we can see, all the reference designators now have a number after them. They don't have the question marks anymore. And now, so what does it mean? For example, if we say we need to use, we want to change R2, for example, for 50K resistors, then we can immediately go, okay, this is R2, and we can say, okay, we want to change this for 50K. As an example, we are not going to change it now. So we are schematic annotated. We can now start associating footprints to these schematic symbols. And this is the biggest difference between like Mentor Graphics' pads, Altium, Eagle, and generally pretty much any else PCB design software. So these footprint, these schematic symbols, if we were to now jump to our PCB layout side, there will be nothing in there, because these schematic symbols don't have a physical symbol or physical footprint associated with them. So, I mean, there's currently no info that the audio amplifier IC is using this kind of package inside KiCad. So now we have to tell KiCad that, okay, use this kind of package with this schematic symbol. So let's do that. So we're gonna go once again on the top toolbar, assign PCB footprints to schematic symbols. It's gonna load up a big number of footprints. Look. There we are. And now the footprint, the assign footprint window will consist of 3 specific sections. You will have the leftmost one that has all the different footprint libraries in them. In the middle, you have it'll show your schematic symbols, and then on the right, it'll show footprints. So, but this is going to be a bit tricky to show with just one window, but I'm gonna try my best. So, for example, let's make these filters a bit more. For example, for resistors and capacitors, I would recommend using the first 2 filters here. Otherwise, you might get some weird footprints that we don't want to use. And then I would also click the view selected footprint. So for example, if I now click any footprint here, it will show me that footprint in this preview window. But in this case, I'm going to be using 0603 sized capacitors and resistors. So if I want to assign my C1 capacitor, for example, what is my C1 capacitor for? Well, if we jump back into the schematic, we can see that our C1 is this capacitor right here. So to select the footprint for it, select your schematic symbol in the middle screen, and then from the rightmost screen or the section, double click a footprint, and then you can see that it now has associated that footprint to that schematic symbol. And so we want to do that same thing for all of our capacitors. So I'm gonna put the same. Actually, can you copy that? Just no. So another way, if you want to assign multiple schematic symbols to same footprint, you can just use Control, for example, and I select multiple ones. So I'm gonna select C2 and C3. I'm gonna double click on the 0603, and for example, it'll now show that symbol. And also, if a symbol has a 3D model 3D model associated with it, you can also check it out by pressing this button here for 3D display. And as we can see, it'll show a little preview of what the component looks like. Now this is a handy way to just check if the selected component is anything it should be. For example, if I select a electrolytic capacitor, we can immediately see that the 2D footprint is different, and then if we check the 3D view, this particular component doesn't have a 3D model, but it will still show the pads and the outlines for the component. Let me just show you what there's an axial. Actually, oh, well, there we go. There's an axial electrolytic. Well, not necessarily electrolytic capacitor, but I can immediately see, okay, this is a wrong type of capacitor. I don't want to use this. But let's select. Oh, let's associate the rest of the components footprint. So I'm going to select all of my resistors. All of them are going to be using the same footprint, and I'm also going to assign an 0603 footprint for them, like that. And now let's select the connector type, or the connector footprint for the connectors as a last thing. So audio amplifier package. Let's see, MSUP. They could be the right component. I mean, it looks pretty identical. What does that other one that it recommended look like? Soik. Also a possibility. So which one is it? Let's take a closer look on the DigiKeys product page, and essentially to the bottom of the DigiKeys product page. And in this, zoom in. Here we see package case SOIC 3.9mm width. So for the most important, it's like 8 pins SOIC. So if we see, well, that is a SOIC, and it's 3.9 times something sized. So most likely this is the correct package for this audio amplifier. So we're gonna select it. Now we're gonna select footprints for our connectors. I'm gonna use well, we could go for the most simple footprint for all of these connectors, and that is a simple pin header connector, which is I mean, you probably are pretty familiar with this one. It's a pin header connector with 100 mil pitch between the prongs. This is we're gonna go with this for all of our connectors. We can, within reason, we can also we can wire all of our things directly to the board itself. We don't actually have to put this connector to the board. So this is this is a safe connector to use if you are a beginner and you don't know like good popular connectors. So we are just gonna go with this for now. So we're gonna select all our connectors and we're gonna double click on that pin header. Okay, apply schematic and continue. So all of our schematic symbols now have a physical footprint associated with them. So now we can go apply, save schematic and continue. Okay, we're done with our footprint selection, and now we can move from the schematic to layout. So we can do that from tools. Or we can do it from, I would recommend doing it from the tools and then update PCB from schematic. This is the simplest way to just do it. Okay, it's gonna show the changes that it's going to be doing. So because we don't have anything on the layout side yet, it's gonna tell us that it's going to be adding all these components, which is correct. So we are just gonna go update PCB, close, and now all our components are here. These are all the components. This is our audio amplifier. This is our enable or mute connector. Let's see. This is our power in connector. Audio in. I'm gonna put it there. Speaker output. And the rest of these components are capacitors and resistors. So, for example, if I'm not sure what this C3 capacitor is, I can select it. Then I'm going to jump back into the schematic. And as long as you don't move your cursor back on top of the window, you can see at the top that the C3 has the marker on it. So the marker was here. So that tells me, okay, C3 is this. It helps you locate where that component is. And for example, another way to do it is if you, for example, zoom in a little bit, then you jump to layout, click one of your components or select one of your components, and then jump back, then it will move the screen over to that symbol. So R1 is this resistor. So let's move our components into place. Okay, we're gonna change our raster for the component placement a little bit. We don't need that. Such a fine raster for this. Where's our C2? It's in there. Okay, I'm gonna disable a couple of things. We have a little bit too much clutter clutter for my taste in the layout screen, so I'm just gonna go here and gonna turn on courtyards, fabrication layers. I speak English good, as you can tell. And well, now it's much less clutter. We can more easily see what we are doing. So let's see, C2, let's take a quick, so C1 and R1, C2 and R2, they are in the audio signal input. So we are gonna group those. So C1, so R1, there's our R2, and there's our C2. Now we are gonna arrange them a little bit more neatly. Let's see. Well, I mean, yeah, that is gonna be just grounded. So put that there, put that there. And then it was flipped. So as again, I'm using pretty much the same hotkeys as I did on the schematic side. So for example, if you want to move a component, you can select it and then press M, so you can drag it around. If you want to rotate it, you can select it and just press R. Not, sorry, I pressed E. So R, it rotates, or you can press M to move the component and then press R to rotate it. So we are just gonna arrange these capacitors and resistors a bit more neatly. And now we can immediately see that we have a pretty nice, clean, easy to route connections for all of these components. There's nothing is crossing over. There's really nothing extra here. So in fact, I'm gonna place these a little bit closer to our IC. I'm gonna leave a little bit of gap between them. Not too much, but a little bit of there. And then I'm gonna move my audio input connector a little bit closer. I would say that is, and also another thing, if you press Alt 3, you can open up the 3D view. So as we can see, the J1 is our audio in connector, and we just placed the C1, R1, C2 and R2. So this is a pretty good, this is an easy way to connect these. So let's actually, before we should we place the other components first before starting to put down some traces? Maybe yeah. I'm gonna do the component placement, and then at the end I'm gonna actually add the traces. So with that, and this is what I meant, you can very easily place your power decoupling cap next to the power pins here. So let's say something like that. Yeah, that's good. Then let's see where this is connected. This is the board, the PCB that we are designing right here. We are going to make it two layer. Two layer is the most common one, or is a very common for like hobby use. We don't need more than two. If we wanted to, we could make do with only one copper layer, but that is a little bit I don't see a reason why we would need to restrict ourselves to just one. So we are just gonna I'm gonna put the weak pull down resistor on the other side. Or maybe I'm gonna put pull down resistor there. And then I'm gonna put the enable connector here, and I'm gonna put our power in connector there. So now we have roughly placed all the components. This is a good time to take a peek in the 3D view, and everything seems pretty reasonable. I mean, it's a very simple circuit. Not a lot of components here, so. But I mean, if you think about it, this is all that you need to have a simple audio amplifier. It is so easy. It is not difficult. There are things. Okay, there's that little hump when you need to like start to learn to do this, but well, as I said in the beginning of this stream, electronics design can be difficult, especially when you start to get more into more advanced and complex designs. But if you're just beginning, stick to simple circuits and you will be able to make them yourself. And then as you make more and different kind of circuits, you will learn, you will get more knowledge, and you will be able to start designing more complex designs. But anywho, at this point, I'm gonna draw the edge of our PCB. So I'm gonna select edge cuts layer. I'm gonna select add graphic lines, and now I'm just gonna do a rough. Yeah. I'm just gonna do a rough outline for the board. And that was a bit of a miss. I might have to. Yeah. You get that error if your outlines are not connected, like there's a gap somewhere. That is what that error is about. I'm going to move these I'm going to move these. I'm going to center these roughly for the board. Here we are. And now if we take a look at the 3D view, this is now this board has the same edge that we just drew in the layout. Okay, I would say at this point we can start connecting all these components. So we are by pressing X, it's gonna move onto the trace tool. So if we can see that our cursor is snapping onto the pads into the pads of the through hole components. So for example, if I move my mouse over to this pad and click, we are now making a trace that we are going to be using to connect all these components. And it'll highlight the pads that you need to connect together. So for example, I can clearly see that I need to connect this pad that I'm drawing the trace from to this pad next to it. Click. Done. Now those two pads are connected by this copper trace that I just made. So let's continue adding those traces. So X, click, click, from this pad here, 3, boom, D, click, clack, donezo. There we are. From here, click, click, click. Okay, I'm gonna show, for example, if you want to remove a trace, there are a couple of ways to do that. You can select a part of the trace by just clicking on it and pressing delete, and it'll remove that selected trace. You can select a trace, press U, and it'll select that whole thing. For example, if I were to make a more like complex trace just for demonstration purposes like this, I could simply select this part, press U, and it'll select that whole thing. Pressing I will also do a same kind of thing, but the difference is that it will also select all the same traces that are on that net. So for example, if I were to select this trace that I just made and press U, it's gonna select just that trace. But if I select it and press I, but then it's not gonna select that one. I don't know, there's some kind of difference, but I just can't remember it now. But usually you can just select parts of the trace and just delete them straight, or just press U and delete the whole trace and redo it. So let's connect these. I'm gonna connect our well, how do I actually, what is the best way to route this part? I'm gonna move this component. Actually, never mind, I'm gonna leave it there. Okay. I'm gonna phone. That sounded weird. Never mind. Oh, yeah, never mind. Sorry about that. So, I'm gonna connect that firewalls there, then I'm gonna do a little sneaky beaky. I'm gonna go here. Connect these like so. I'm gonna bring this connector a little bit closer, and then I'm gonna connect it like so. And now I want to connect this ground to a hole, this pad to a ground by a via. So how do I do that? So press X, start making a trace, press V. Now it's gonna make a through hole via. So what this is here, so what this is essentially, it's gonna do a copper plated hole through the board to the other side. And now we have essentially everything is connected now. These, we can still see that there are a couple of unconnected connections on the board, and as we can see, if we press ESC a couple of times on the bottom here, it says unrouted to, and those are these two connections here. So what we are going to do now is we are going to do a flood on the board. We are going to fill, we're going to do a copper pour, flood, fill. Anyhow, we're gonna fill the board with a single net trace. So what does that mean? Well, let me just select my top copper here. I'm gonna select add filled zones. Then I'm gonna trace an area. I wanna I wanna connect this fill to ground net. We can leave all these other settings to default for now. So we're gonna do here, we're gonna do a thing like this, and we're gonna double click to close it. And as we can see, now the board has a ground fill on it, and we can select it from here. For example, if I move it here and I press B, it will refill, but it will always stay on the board. It will not go beyond these edges here that we made earlier that show the edges of the PCB. Yeah, I think it's gonna work. I'm gonna add another through hole via here for this ground, because this part here is a bit skinny for my taste. And now we have a flood on the top layer of the board, as we can see, but our bottom is completely bare. There is no copper apart from these through hole pads and these couple of through hole vias that we made. So we're gonna make that same flood on the bottom of the PCB. So the easiest way to do it is to select the flooded zone, Control D to duplicate, and then don't move your mouse, just press enter, press E, and then select the bottom copper, and also keep it on the same ground net, and bam. If you want to change quickly between top layer and bottom layer, you can do it from page up and page down. And if you don't want to see this flooded copper here because it covers quite a lot of things, you can select this do not show filled areas in zones, and then you can again see just a normal board, or then board without any filled zones. But that is essentially it. It's done. Oh, now it's minimally done. Now we can do a little bit of refinement. We can add a little bit of flair to it. So what we are gonna do is we are gonna add some silk text. So we are gonna select. Okay, what we're gonna do, we are gonna leave this bottom side, top side. We're gonna leave this top side untouched. We're gonna leave it as is. Well, actually, I'm gonna move these C1 and R1 designators out from so that they aren't under the R2 and C2's pads. So I'm gonna do that. Click. I selected the C1 with shift. I'm gonna move them. It's just a little bit of a tight fit there, but I think they might just fit. I think they are okay there. It's a bit of a tight fit, but that should work. So just to make the use of this board a little bit easier for ourselves, we're gonna add some silk text that shows us what these connectors are, because now we are they are just pin headers on the board, but we don't really know what they are for. So what we are gonna do is we are gonna add on the bottom side of the PCB, we're gonna add some silk text here. So jumping back to the layout, we are gonna select B silk, which stands for bottom silk. F silk stands for forward silk or top silk. So B silk, then we are gonna select text or add text. We're gonna add we're gonna add speaker out. Click. And now, as you can see, this text is mirrored. Why is it mirrored? Well, because we are looking in the layout, we are looking at the board from the top side. So, and because this text is going on the bottom side of the board, it means that it has to be mirrored. So in fact, if we go to the 3D view and we orbit to the back side of the board, we can see that the text is the right way. And we are gonna use these texts to quickly describe or give a simple visual representations what these connectors are. So we're gonna copy that. We're gonna Control D for duplicate. We're gonna go for audio. Maybe go for audio in. And we're gonna duplicate that. Power in. That was a weird ghost there. And that is enable. That we can place there, that we can fit there, that we can place, let's see, let's place it there. Let's put this here, and now let's take a peek at the 3D view so we can get a little bit of a better idea how it will actually look once we get the boards. It's not perfect, although I don't know if we are. If it's that important. I mean, it's a simple board. It's a very simple board. I don't think it needs to be more complicated than that. I think I'm gonna simplify them a little bit. I'm gonna remove the second line from them. And I'm gonna show them the speaker to just SPKR. That way, and then I'm gonna audio. I'm gonna place that there. Okay, I would say that's pretty good. Now we're gonna add some plus and minus symbols to these outputs so we know which one is the positive and which one is the negative input or output. So we're gonna go, let's make a new text. We're gonna just go plus, minus, and that is the correct way for that. And it's the same thing for here. And then, oh, don't wanna go there, and like so. There we are. Now we can easily, without any extra effort, we can easily figure out what these connectors are and which one is a positive and which one is a negative. And I would say with that, the board is complete. So we can step into the next step, which is to produce the Gerber files. Gerbil, guinea, pig, Gerber files. Gerber files are the files that the actual PCB manufacturer use to make the boards. So let's make them. I'm gonna hop into the project folder and I'm gonna make a new folder in it called Gerber. Yeah, it's just for organization's sake. Then we're gonna jump back into the PCB new, our layout program. Then we are gonna go to this symbol over here in the top, which says plot. we're gonna select our output directory, and well, I mean, you could also create a new folder from this end, but I already created it from Windows Explorer. So select the Gerber folder, select, do you want to use relative path? Yes. Then we're gonna have to specify what layers we need to use. Well, because this is gonna be just a 2-layer board, the layers that we need from this section are the front and bottom copper layers, front and back silk layers, front and back mask. Oh, these are the solder mask layers, and then the edge cuts, which tells the edges of the PCB. Then we want to check the use ProGel file name extensions, include extended X2 attributes, and include advanced X2 features, and also subtract solder masks from silk screen. With that, we can just press plot. Now it has generated these Gerber files, but we also need to generate a drill file. Let's jump into there. These are the settings that I use: file format, Exelon, drill map file format, PostScript, drill units, millimeters, zeros format, decimal format, and Exelon drill file options, PTH and non-PTH holes in single files. So this just means that it puts what these acronyms means are play the through hole and non-play the through holes. So they will be put both into the same drill file. You don't need to know what the difference is at this point, and I don't think the drill origin. I've been using absolute, and I don't think it actually matters which one you use. I would say use absolute. Well, I mean, I've been using that and I haven't had any problems getting my boards made. So now it's gonna automatically use the Gerber folder if you selected it in the last window, and then we're just gonna go generate drill file, and there we are. Close, and now we have our Gerber files that you need for manufacturing your PCB. There's one good thing that you should always do before generating your Gerbers, or at least before you order them, and that is to do the idiot check from perform design rule check, and just .dsc. And as we can see, there are no markers, so our board's design is okay. There is no, well, for the sake of demonstration, I'm gonna make a DRC error on the board. I'm gonna make another trace, gonna put it near that pad, and then I'm gonna select this, press E, and I'm gonna make it thicker, like that. Now, this trace is invading into the clearance area that all the pads have around them. Now this will give a design rule error. Start DSC, jump, yes, refill. And as we can see, now it gives a marker. And the error is track near pad. Well, we made a track and it's too near that pad. So for example, if we remove that trace and we do a new check, it's gone. So I would say that this is a minimum thing that you should always do when you are designing PCBs. Do the idiot check, just run the DRC check, because if you have problems here, there is probably something weird going on with your design, and not in a good way. Also check the list on unconnected. So if you have, for some reason, you have not noticed that there is a unconnected connection left on the board, then the least unconnected will highlight it and show you where it is. But in this case, I'm just gonna Control Z and get that trace back. And as we can now see, DRC doesn't give any errors. Least unconnected doesn't show any unconnected connections on the board. So with that, because there wasn't any errors on the board and we generated the Gerbers, then the Gerbers should be fine. So now we can move into the next step. We can select all your Gerber files. You need to have some kind of like packing and unpacking software to do this, but I personally have installed the free 7-zip, so we're gonna make a zip file out of these files. Then we are gonna jump into our browser. We are gonna reset the zoom on my DigiKey page. Then I'm gonna navigate to JLC PCB. Sorry. Burp. Then I'm gonna log in. I'm just gonna use my Google login. Then I'm gonna go to calculate. Before we go any further, just to give you a little description what this site is. JLC PCB is a Chinese prototype printed circuit board manufacturer. Over the years that I've been designing, prototyping and making or ordering PCBs manufactured in China, I would say JLC PCB is the best one that I have found so far. They have I really haven't found any cheaper place like in the business other than them. Like they are one of the cheapest. I don't know any cheaper place, and they have a very fast turnaround time for the actual PCB manufacturing. Like it is crazy fast. And then they usually, I live in Finland. China is roughly on the other side of the planet. Usually when I order my boards, as long as I ship them via courier, I use DHL personally, I can get the boards on hand in a week. That's how fast they are. And the boards have been good quality. I'm not saying that there aren't other places that do better quality boards, but I don't think there are places that make these quality boards for this price point. Like they are really good at what they do. So to summarize, JLC PCB is a Chinese PCB manufacturer, and I personally really like them. So we're gonna jump into calculate. Then it will ask us to add your Gerber files. Gerber. Is it with J or G? Gerber or Gerber? Okay, I'm gonna jump into project workshop folder, mono audio and beginner. Gonna go to the Gerber files, and then I'm gonna select the zip that we just made from the Gerber files. Now it's processing them. There we are. And there's our board. This is the this is a reconstruction of the board from purely from the Gerber files. So I'm just looking a little bit on the board. I'm thinking, well, I could use a little bit more ground patching vias, but yeah, should be fine. It should be fine. And this is always the worst part. You have your Gerber files ready. You're like ready to order, and they're like, "Is the design good? Is there anything that I should fix?" But I would say this is a good enough for a beginner board. If your first board looks like this, I would say congratulations, that is a very good board for a beginner to make. Like, I will be impressed if you first get me to believe that that is your first board you have ever designed. Because I probably wouldn't believe it. But we are just gonna go that everything is okay. I don't really see anything wrong with the board. I mean, for a first iteration, it's good enough. So now we can select okay, it's a 2-layer board. Dimensions, it should load automatically based on your Gerber files. Then it's gonna ask how many like what's the quantity you want. Well, 5 is the minimum, and usually if you like order once a week, or the special offer refreshes once every week, you can get those 5 boards for $2, and that's cheap. That is really cheap, like real cheap. And we don't really need to care about the rest of these options. So there's really nothing else to then just go save to cart. And with that, I would say that the design phase of this board is complete. Now we are nearing the end of this stream. I'm gonna order the boards. I'm gonna order the components, and then we are gonna come back to this stream when I have gotten the boards and the components, and then I'm gonna show you the assembly of the board, and I'm gonna show you how it works, or sometimes if it works. But I really don't really have a doubt that why this audio amplifier shouldn't work. We're gonna get some speakers. We're gonna make some noise. And I don't know, this is my first ever stream. I don't really know how to like end it, so I guess we are gonna get back to our mono audio amplifier once I get the boards and the components, and then we are gonna assemble this thing and see if it works. And I would say with that, I thank you for watching. If you're interested in learning more electronics, subscribe to the channel. This is a new channel. There isn't a lot of content yet, I know, but I plan on making a lot more stuff for this channel. Everything from like beginner design to a like novice, advanced, and then like real complex design. So, and also I am open to any like design topics that you might have. So if you have like an idea, like, oh, could you design an Arduino shield for RGB LEDs? Let's say something like that. That is something like I am open to ideas for videos and what to design. But I would say with that, thank you for watching. If you're interested and you want to see more, subscribe to the channel. If you want to just leave a comment on my first ever stream, that would be appreciated. I know it's I plan on making long form content. I plan on showing the whole design process. I'm gonna show you like from the just the idea, what are we designing, to the component selections, reading through the data sheets, figuring out what the ICs need, what like supporting components they need to work, and then moving on to the schematic design part, and then layout, generating the Gerber files, ordering the boards, ordering the components, and then assembly and testing. Like I plan on showing you, if because I'm streaming, I don't want to cut this down. I want to show you the whole thing, all the ups and downs. I'm gonna show you the dirty truth. It's a dirty job, but somebody's got to do it. And with that, I thank you for watching, and I hopefully I see you next time.